Hi students, welcome back to the class. Today we are here for another session of equilibrium. Today we will discuss about ionization constants of weak acid and ionization constants of the weak bases. So first let us see for weak acids. For that we have to consider an acid HX. Here H means the proton and X is the negative part. Okay, for example HCl. So Cl will be X plus water. Since we are dissolving it, we have to add the water. Now this attains the equilibrium in the reaction as hydronium ion, which is H3O positive and X negative. Okay, as you know that the acid releases the proton, so this H will add up with the base here, okay, H2O, and you already know that water can act as acid as well as base. So since this is an acid, it will act as base. If this was base, it will act as an acid. Okay, so this proton which is released by the acid is taken up by the base and it became H3O positive hydronium ion plus the remaining part, okay, the negative part, that is X positive, X minus. Now initially what is happening before the reaction was starting, only the concentration of the reactant was present and there was no product formation. So initial concentration is, let us consider this as C and this to be as 0. Okay, but suppose after some time reaction has occurred. Okay, alpha is the extent of the ionization, means how much of the molecules has been converted into ions. Okay, how much of the product is formed. So for that you have to do here minus C alpha. Now a very important concept is that suppose X number of molecules is there, out of that X 1/4 of the molecule is ionized, then how we can write what is the number of ionized molecules? 1/4 of X, right? If C alpha is the number of ions formed as products, then that many number of molecules has to be lessened from here, right? Because from here only, from the reactants only, the products are forming. If 5 molecules of hydronium ion and X minus is forming, then 5 molecules of HX should also leave this side, then only products will form. So if C alpha is the number of ions formed, then from the initial concentration you have to remove the C alpha. So initial concentration minus the number of molecules that are ionized. Okay, so C minus C alpha. Clear? So see here also it's C alpha. Now in order to take the equilibrium constant, you know that we have to multiply the concentration of the products, okay, divided by the concentration of the reactants. But here in the expression the concentration of water is constant, so constant into constant, you will get what? Another constant. Like 5 is a constant, 3 is a constant, and if you multiply both you will get 15, which is another constant. Okay, so here let us consider that particular our new constant be Ka. Okay, equilibrium constant be Ka, and this is known as ionization constant of the acid. Okay, A is nothing but it is denoting the acid. Okay, A. Now we have the concentrations of the particular ions. Now hydronium ion concentration is C alpha. Okay, for this also it's C alpha, and it was for the reactant it is C minus C alpha. Now if you multiply you will get 2C are there, so C square alpha square divided by, take C common from here, what is left? 1 minus alpha. Now this C and 1C from the numerator will get cancelled and you are left with C alpha square divided by 1 minus alpha. Clear? So this is the expression for ionization constant for the weak acids. Okay, so larger the value of Ka, stronger is the acid, and if it is less, then the acid will be means less stronger. Okay, weak acid. Now the similar formula is applied for the weak bases, except that the reaction is different here, because you know bases are those substances which releases the OH hydroxyl ion. Okay, so OH is the hydroxyl ion according to the Arrhenius concept we are using here. Okay, for acid and base we are using the Arrhenius concept, which said that acids are those substances which will release the H positive or proton, and bases are those substances which will release the hydroxyl ion. So in that context we are taking this reaction. Okay, M is any metal. Okay, M will go for any metal. For example, sodium hydroxide. So sodium is a metal and it is denoted by M. This is actually a generalized reaction. Okay, you can put any metal for M. Now this metal will get ionized, okay, positive, and the hydroxyl is negative charge, so it is OH minus. And by using the same method you can obtain for Kb equal to C alpha square divided by 1 minus alpha. Now the relationship between the ionization constant of acid and ionization constant of base is that if you multiply both the values you will get the ionization constant for water. Okay, you have already derived Kw in the last class. Let us move on to the next topic, that is di and polybasic acids and di and polyacidic base. Okay, you know the example of hydrochloric acid. Okay, the formula is HCl, where there is one, if you ionize this, what you will get, one proton and one chloride ion, right? But there are some acids where you will get more than one proton. For example, sulfuric acid, you can see here there are two hydrogen, right? So you can ionize this as this following. First, let us go step by step by taking a generalized equation where there are two hydrogen and one negative part. It can be sulfate, it can be chloride, okay, but there has to be two hydrogen or more than that, then only you can say that it is polyprotic acid or polybasic acid. When you ionize any polyprotic acids, first of all it will release only one proton. Okay, in the first step it will release only one proton, and what is left? If one proton is released, only one hydrogen and X is left. Okay, so HX negative, because one positive charge has gone out from H to X. I am saying it in a simple way so that you understand. Okay, so and it will become negative, so proton is positive and this is the negative part. Okay, negative radical. Next, one more hydrogen is there, right? So you can release one more proton. So again we will take this and release the proton. H is released, what is left? X, 2 negative. Okay, so every time you release a proton from a molecule, that molecule or that species or that ion will acquire more negative. First of all it was neutral, it was zero charge. Okay, you have released one positive charge, it will become one extra negative. Okay, just remember it in a simple way. Whenever I am saying that it is a neutral molecule in terms of charge, there are equal number of positive charge and equal number of negative charge. Okay, if I remove one positive charge, one negative will become extra, because this positive is cancelled with this negative, this positive with this negative. Okay, they are counteracting, but now one negative is left here. Okay, it does not have the particular positive ions. Clear? So it becomes negative here. Now already one negative was here. Okay, now you remember that this is not present here. Okay, so this is HX negative, means one extra negative was already there. From here again you have removed one proton, so here it will become 2 negative, because one more proton you have released which was positive in charge, right? So this positive will counteract this negative, and how many negative charge you will get here? Minus minus. Okay, 2 negative. Clear? I hope this is clear to you all. Okay, so neutral means the positive and negative charge is equal, and if you choose to remove the positive charge from that particular substance, that particular substance will become negative charge, and if you remove the negative charge it will become positive charge. Okay, so this is the whole concept. Clear? Now if you add this, what you will get? First of all, you will get 2H positive here, right? If you add this, then this and this one will get cancelled, so you cannot write. What is left here? X2 negative, and into your left hand side H2X. Clear? So if you try to break down this particular hydrogen sulfate, then also you will get the same sulfuric acid, you will get the same pattern. Okay, you will get 2H positive, and the particular anionic part that is present, that is your sulfate here, will acquire 2 negative, because from here you have released 2 positive charge. Okay, 2 proton. In this example also you can see there are 3 hydrogens, so 3 protons will be released and the anion will acquire 3 negative. Okay, so in the first stage also you can take out the equilibrium constant. In the second stage also you can take out, right? So in the first stage, that particular ionization constant is known as first ionization constant. Okay, and then you will get the second ionization constant. Here also you will get 2 ionization constant because 2 hydrogens are there, but here you will get the 3 ionization constant because 3 steps will be there, and in every step you can take out the ionization constant. The first time you take out is known as the first ionization, the second one is known as the second, and third step is for the third ionization constant. Okay, now let us go to the last topic here, that is the factors affecting acidic strength. Okay, first of all you have to be very clear that according to Arrhenius, you know that an acid is a substance which releases the proton. Okay, so those substances which will release the protons will be acids. Okay, and those that cannot release are tend to be bases. But also all acids do not have the same capacity to release the proton. Okay, because of different factors. Now that those factors are due to strength, and another one is due to polarity. Strength means the bonding between the proton and the rest of the molecule, rest of the part of the molecule. Okay, so one proton will be there. Let us take one proton only because just now you have studied more than one proton, but consider that the bonding between one hydrogen and the rest of the part. Okay, so here if this bonding is very strong, if this bonding between them is very strong, they will not leave each other. It will become very difficult to separate them. It is becoming very difficult for us to release the H positive or proton. In that case, you can say that the acidic character will decrease. Okay, if the bond between them is very strong, this A will hold the hydrogen very tightly and it will not release the proton easily, and the substances that are not releasing the protons easily will be either base or it will be very less acidic, because character of acid is to release the protons easily. The faster it will release, the stronger is the acid. Clear? And if the bond is very weak, then the hydrogen will leave A very easily, and you can say that that particular substance or that particular compound is a strong acid. Clear? Next, polarity. Okay, so now here you have to know one term, electronegativity. It is actually the property of a substance which helps that substance or element to withdraw the electron towards itself. Clear? So the more electronegativity means that a particular element will withdraw the electron towards itself more, and if less electronegative means that particular element or substance will withdraw the electrons with less tendency. Okay, they do not have the tendency to take up the electrons. Now you take this only as example. Okay, H and A. If there is a high difference between the electronegativities of A and H, that means what? Suppose this A is having very high electronegativity, means very high tendency to attract the electrons, and H is having very less tendency to attract the electrons. Okay, then what will happen? This is having very less tendency, this is having more tendency, so there will be no competition between them, and A can take up all the electrons, the ones that hydrogen has shared. Hydrogen is sharing one here, right, one electron, so this A can take up the whole electrons, and ultimately what will happen? Whenever bonding is taking place, means what? They are actually to some extent they are sharing the electrons, right? So if A is taking up all the electron towards itself, then A will leave out from here, from this substance. Okay, so there will be no relationship between H and A. There will be no bonding because A has taken up all the electrons for itself, right? In that case, the release of hydrogen becomes easier. Okay, and then you will get a more acidic character or more acidic compound. Clear? But if their electronegativity difference is very less, there will be a competition. H will also try to pull towards itself, A will also try to pull towards itself, so they will they will have similar electronegativity and no one is going to leave the electrons. Okay, and ultimately what will happen? They will tend to share the electrons and no one can take the electrons completely towards itself, and the release of H in that case will become very difficult because H is also pulling the electrons and A is also pulling the electrons, so the release of H will not occur easily from A, and in that case we will get a base. Okay, or we will get a very less acidic substance. Okay, I hope this is clear, and just you read the sentence here. When difference between the electronegativities are high, the separation becomes easier. When their difference is high, this A will pull the electron towards itself more and it will release the hydrogen ion, okay, proton. That indicates stronger acids. Okay, I hope this is clear.